Here's the next question, number 20. An inductor is connected in parallel with a capacitor shown in the figure. As the frequency of current I is increased, the impedance Z of the network varies as we have our options A, B, C and D. Now, in order to solve this, let's look at the figure given. The inductor and capacitance are connected in parallel, which means that the impedance, if we have to find out the effective impedance, then that would be the resultant of the parallel combination between the two, which is ZL in parallel to ZC. I'll write it here. So Z effective would be ZL parallel ZC. And to write that, we have our expression ZL ZC divided by ZL plus ZC. This is the formula usually used for parallel combination. Now, if we are to expand this and write it in terms of j omega, we get this as j omega L into 1 by j omega C divided by j omega L plus 1 by j omega C. Now, if we take j out as a common term, we can resolve it by taking the resolving the denominator over here, omega L divided by 1 minus omega square LC. Resolving that, we get this. Now, for different frequency, we observe the waveform to resemble B option here, because now when we have our expression this way, frequency here, for different frequencies, there is a change in the waveform. So because of the expression given here, we have inductance in the numerator and we have both inductance and capacitance in the denominator, which is obviously less than 1. Now this expression here is non-negative. So we will have our waveform or our expression to show an increase first this way, which resembles our inductance. And then we have a waveform to resemble here for capacitance. So capacitive, in fact. There's a capacitive quality in the waveform there. And if we notice, we see that it resembles option B. So option B here is the right answer. It all depends on the expression that you get here, where the inductance is in the numerator and the entire expression as a whole is non-negative. So using that, keeping that in mind, you will be able to find out which is the right waveform among the options.